Alright guys, here's your quiz help video for our upcoming quiz this Thursday or Wednesday. Use the definition of the derivative. I should have put limit definition. Use the limit definition of the derivative to find the derivative of each function with respect to x. So notice it says the limit definition of a derivative. It doesn't say the alternative form. The limit definition of a derivative is the one where you can use delta x or h. I'm going to go ahead and choose to use h. But it's the one that looks like this. Okay. So, without any further ado, let's begin. So the first thing that we're going to do is we want to figure out what is I think it's going to be a rather large expression. So f of x is just this, right? But we also need to take a moment and figure out what is f of x plus delta 8. I'm sorry, f of x plus h. So 3x squared plus x plus 3. So we have 3x squared plus x, was it plus 3? I forgot, sorry. Yes. Okay. Now we're plugging in x plus h here. So first of all, we talked about a shortcut for that so that we don't have to always do that manually. It's kind of irritating. It's x squared plus 2xh plus h squared. This one's going to stay the same. We also need to distribute here. So we get 3x squared plus 6xh plus 3h squared, etc. And then I don't see any like terms that we can combine here. They all look different. So I'm going to do my best to remember that and transfer it over to the next page. Here we go. So it was 3x squared plus 6xh plus 3h squared plus x plus h plus 3. And then after you guys do that, you're going to go ahead and simplify on the top. So the first thing we do is distribute this negative in, which is going to make all these numbers become opposites. So this is going to be a negative, negative, and negative. And that cancels that cancels that, and that cancels that. And in case you don't remember when you're doing this method, everything over here usually cancels at least one thing over here. Now we have the limit as h approaches 0 of 6xh plus 3h squared plus h over h. And now we're going to reduce. So what I can do is I could divide this h into each one of these. So if I divide h into here, I lose that h. If I divide h into here, we lose one of our h's, so it's just one h. And if we divide h into this, it becomes 1. And so now we have 6x plus 3h plus 1. And then after that, you go ahead and do your direct substitution. So, oh, this is supposed to say h is approaching 0. So I'm going to plug 0 in for h. This goes away. Final answer is 6x plus 1. You can know you did it right because you guys already know how to do the shortcut, right? Derivative of this is going to be 6x. Derivative of that is 1. So that's your answer. But you have to show your work, okay? Now our quiz tomorrow is not going to be a multiple choice quiz. These problems, I'm pretty much going to be looking for your setup, okay? And definitely your answer. And I'll probably also look at your work a little bit too. Does your work actually lead to your answer? Okay. So in other words, you can't just show the setup and write the answer. You need to show me how you got there. But pretty much your 2 big points are coming from your setup and the answer there. All right, let's go ahead and take a look at another one here. Same thing, different function. So the limit as h approaches 0 of. Nice setup. This one's a little bit easier to find out what x plus h is. The function is f of x plus 4. If I put x plus h in here, what I'm going to end up with is the square root of 5x plus 5h plus 4. Okay. Now the strategy that we learned for this is rationalizing. So what we do is we multiply the top and the bottom by, let me create a little writing space for myself here. We're going to multiply the top and the bottom by the same thing, but with an opposite sign there in the middle. And whatever we do to the bottom, we have to do the top. Or whatever we do to the top, we have to do to the bottom also. So plus. Okay. So let's see what that gives me. Now when you do this on the top, basically you end up with the same expression that you had before, but just no square roots on it. Because this times this just eliminates the square root. Minus, I would put those in parentheses if I were you. And then square root of 5x plus 4 times square root of 5x plus 4 is just 5x plus 4. And then, of course, on the bottom we have the following. Okay, now on the top here, I'm going to distribute this negative. That's going to cancel this 5x with this 5x and this 4 with this 4. And now I have 5h over h and then all this crazy stuff here. Okay, so the h's go away. And then we do direct substitution, which is going to make this go away. And so now I have the following. I've got 5 over the square root of 5x plus 4. The h is gone. Plus the square root of 5x plus 4. And when you have two of them, the way you write it is you just put a 2 in the front of one of them like that. And there's your answer. Okay? Let me see here. I feel like some of these should have been alternative definition of a derivative. Oh, okay. So we'll do one more. All right. This one we want to find what is the limits of this function as h approaches 0. We're going to have 2 over, if I plug in x plus h here, I'm going to get 2x plus 2h. And then plus 5, and there's a negative in the front, don't want to miss that. And then minus the original function with no h. Okay, so notice that these double negatives are going to be positive. Let's do that first. And we have h here. Okay, so now for these ones, we are going to rationalize, not rationalize it, we're going to get rid of the fraction, basically. All right, this might get a little noisy here because the lunch bell just rang. Some people will probably come in here, but I'll keep going. So what I'm going to do is I'm multiply everything by the denominators. So I'm going to multiply here by 2x plus 5. I'm going to multiply here by 2x plus 5. I'm going to multiply here by 2x plus 5. In this case, this one will cancel this one. And now I will have the following. Hello. Sure, it's right there on top of my printer. Help yourself. All right, we'll see you Friday. Okay, we're going to repeat that now with the other denominator. Oh, I made a mistake actually. Here, they canceled, right? So at this point, we should only have a 2 here. Okay, now we're going to repeat this, but this time we're going to do the other denominator. So now I'm going to multiply everything by 2x plus 2h plus 5. Okay, so now in this case, this one will cancel this one, and that's why we did it. Let's see what we have left now. Hello.
It's working.
I know, it got warmer. Yes, sir. Help yourself. It's right there on top of the printer.
Where's your lunchbox? It smells good. Oh, sorry, you're making a video?
I am, but that's okay. We can have a little background conversation while I do all this tedious stuff. All right, now what? Okay. So at this point, I think we're going to go ahead and distribute the -2 and the +2 in there, okay? Mm-hmm. Yeah, I don't know. I think it's just trying to warm up a little bit.
Okay, I just want to do your
Go for it. So if I distribute the -2, we get this -10 plus, and then distribute here as well. We get 4x plus 4h plus 10, and once again, we have some cancellations happening here like we always do. The bottom is going to stay the same pretty much. Hello. It's weird. All right. And then this h is all that's going to be left on the top there. So I'm just going to go ahead and erase all that just so it looks a little bit more clear. And since all that is up there now, this h can reduce with this h. So here's what we have now. Then we do our direct substitution, and that cancels that out. And so basically I just have 2x plus 5 times 2x plus 5 on the bottom, which is 2x plus 5 squared. All right, and so for the next problem here, we're going to be finding the derivative at a specific value of x using the alternative form of the limit definition of a derivative. That one looks like this. All right, so here we go. So the limit as x approaches c, which in this case is -1, is equal to the function minus the value of the function at this point. So I need to plug in -1. It's going to be 5 minus 3 minus 4, which is -2. Then on the bottom we have x minus c, and my c once again is -1. The double negatives becomes a positive. From there, that's your setup, so that would be worth a point there at least. From there you're going to go ahead and simplify, so this becomes a +2, and +2 and -4 make -2. And then we got to factor it to remove the discontinuity. Now I know one of those has to end up being x and 1 because that's how the discontinuity gets removed. Let's see, does that work for us? Hope it does. And so after you factored it, you're going to go ahead and cross off what they have in common. And then after that, you're ready for your direct substitution. So plugging in -1 here, we would get -5 minus 2, which is -7. So there's your limit. Okay. Let's go ahead and do another one. So for this one, our C value that we are approaching is -8. And my function minus the value of my function at that point. So I'm going to plug in -8. That would be positive 32 plus 4, which is 36, which is 6. And then x minus a -8, which is x plus 8. So there's your setup. And then we're going to go ahead and do the limit method. The method that we would use here to find our limit would be the rationalizing approach. So I'm going to multiply the top and the bottom by the square root of -4x minus 4 plus 6. And don't forget, whatever you do to the bottom or top, you also do to the bottom. Okay. So this times this would cancel out the root basically, and we'd be just left with the binomial itself. And then positive 6 times -6 leaves me with minus 36. And on the bottom we have x plus 8. And then we have our little square root expression down here as well. Okay. Combining terms, like terms in the numerator, would be next. So that would give me -4x minus 32. Now at this point, we're still not quite done because I haven't removed my discontinuity yet. And the reason why is because this needs to be factored. So what can we take out of the top there that those two things have in common? They both can be divided by 4. And since there's a negative in the front, we're also going to go ahead and take out a -4. So if I divide both of these by -4, I would end up with x plus 8, and there's the part that needs to get removed. Okay? Okay. Now we are ready for our direct substitution. So I'm going to go ahead and plug in this -8 here. Now if I plug in -8, that's going to be 32. Oh, was that supposed to be plus 4 all along? I think I've been writing that wrong. So 32 plus 4 is 36. The square root of 36 is 6. 6 plus 6 is 12. So if I plug in -8, the bottom ends up becoming 12. So now I've got -4 over 12, which can be reduced to -1/3. Okay, so that is the limit definition of a derivative and the alternative definition of a limit, or a derivative according to limits. So, oh, I've got another one here. I didn't realize I'd given you 3 of these. We'll do one more, I guess. Okay, so for this one, we're finding the limit as x approaches 0 of our function. When we plug in 0 for x, we get 1. And x minus 0 would just be x, so we don't really even need to write -0. So we have a complex fraction here, so we're going to multiply everything by the little denominator there to cancel it out, right? Okay, so what does that give us? We have 1 in the front now, because those are all gone, minus 2x plus 1 over x times 2x plus 1. Don't really need the minus 0, so I just put x instead of x minus 0. All right, let's go ahead and distribute our negative here. So that makes this negative and this negative. And so now we're going to have 1 and 1 cancel, and I'm left with negative 2x on the top. And my discontinuity cancels. So this x and this x cancels out. And now I'm left with the limit as x approaches 0 of negative 2 over 2x plus 1. I don't think this 2 is supposed to be here. Let me erase that. There we go. All right. And then we do our direct sub. Plugging in 0 here, this goes away, and we're left with negative 2 as our final answer. Okay, moving along. Another thing that we'll be dealing with is these guys, where you should be able to look at a particular limit problem and realize, hey, that's not just any old limit, that's the limit of a difference quotient, which means it's actually a derivative. So you're going to be asked to do 3 things. What function does it represent the derivative of? At what value are we finding the derivative? And then finally, we're going to use our shortcuts to find the derivative. Now, some of these derivatives I'm giving you can actually you could probably just do the limit like we've been doing, but it's up to you how you want to go ahead and solve it. So now, in these problems, whenever you're looking at the regular limit definition of a derivative, this number is your c. And if you cross off the h and replace the number with an x, that will tell you what the function was. So if you replace the number with an x and get rid of the h, that will tell you what your function is. So for part A, my function is y equals the square root of x. And for part B, the c value that we're finding the derivative at is 2. And so now for part C, we're going to do our shortcut. The derivative of a square root function is 1 over 2 times that square root. And then we're going to plug in the 2. I don't like that. Oh well. And there's our answer. It's pretty much the gist of it. Okay. Let's go ahead and take a look at another one here. For this one, notice my c value is pi over 4. The function is what I would get if I replaced this with an x and got rid of the h, so it's cosine of x. And now we want to find f prime of c. So, since my function is cosine of x, the derivative of cosine is negative sine of x. And we want to find the derivative at x equals pi over 4. Sorry about that. So we're going to plug in pi over 4. And sine of pi over 4 is square root of 2 over 2. And it's negative, so we end up with our final answer of negative 2, radical 2 over 2. Okay. Just got a couple of these. So in this case, my c value is 5. My function is ln of x. And we want to find the derivative at 5. So if my function is ln of x, then f prime of x is 1 over x, and the derivative at the value of 5 would be 1/5. And so that's what this limit equals. All right. Moving along. Now we're switching from the standard limit definition of a derivative to the alternative form. When you're looking at the alternative form, it's not h approaches 0 anymore. Now it's x approaches some other number. And that other number is your c value. Okay, so my c value is going to be this number here. Okay, the function is always going to be the first part of the expression. And then we want to find out, so what is f prime of 4 then? So we know our function is 1 over x minus 3 to the 5th. That means that f of x is equal to x minus 3 to the negative 5ths, right? And what we're going to do to find our derivative is we're going to do the chain rule. So we're going to multiply the negative 5 to the front. We're going to take 1 off of the power. And then we multiply it by the derivative of the inside, but that's just 1, so it doesn't really matter. And therefore, if we want to rewrite our derivative in a more normal-looking form, we have negative 5 times 1 on the top, and on the bottom we have the binomial now to the 6th power. Okay, so that's our derivative, and we're finding the derivative at 4. So f prime of 4 would be negative 5 over 4 minus 3 to the 6th power. 4 minus 3 is 1, and 1 to any power is 1, so the final answer is negative 5. All right, we might have 1 or 2 more. Last one, here we go. Okay, there's my c value. So that's what I'm finding the derivative at. There's my function. And so if my function, I want to find f prime of negative 5 now. So if my function is negative 2x plus 4 squared, then my derivative would be, multiply that to the front, take 1 off of the power, now it's just 1. And then if I want to find out what f prime of 5 is, or negative 5, I just plug in the negative 5. That's negative 1, and negative 1 times 4 is 4, so the answer is 4. All right, so that's it, guys. That's our quiz for this Wednesday. It's not multiple choice. It is written this time. There's no way to really do a multiple choice test with these types of questions. I could make these last ones extra, or not most extra, I mean multiple choice, but I don't think it'll turn out that way. I think that it's all going to be written by hand. So that's pretty much what you guys can expect, and we'll see you guys tomorrow on Wednesday.